The next presenter is a paradigm flipper. He's going to be telling us about thinking in reverse logic, using breakthrough thinking to say, let's not try and cool the data center, let's not cool it at all, and let's capture and extract that heat generated and use that in some useful way. Isn't that interesting and refreshing way of solving the same problem, but tackling it from a totally different point of view? Please help me welcome to the stage our next speaker, and he's going to be talking about immersed computing data centers for high-density cloud. Please welcome Rolf Brink, the founder and CEO of Asperitas Data Centers. Rolf, welcome.
Thank you very much. Thank you. I'm here to tell you a story. And this story is something that started in July last year. We were sponsoring an event in the UK called Data Center Transformation. You may have heard of it. If you haven't heard of it, it's a very nice event. Please check it out. Last year, with our sponsorship, we decided to launch a white paper called The Data Center of the Future. And this white paper is focused on describing the potential of liquid technologies in data centers. And it's focused on energy reuse. It outlines the blueprints, the basic blueprints of an energy-producing data center. And I'm not talking about an electrical plant, I'm talking about heat generation. You can download this white paper on the website, it's available on a stand, so I won't get into the details of what is in that white paper. What I am going into today is what this white paper has meant to Asperitas in the last half year. Because something happened to us after we launched this. We gained traction in an industry that most of us in the data center space don't really consider in our day-to-day business, and that's energy. What you have to understand here is that energy companies are faced with a big challenge, and the challenge is especially present here in Europe, and it's called electrification of heat. Basically, it comes down to the fact that we're trying to get away from burning gas to create heat. And in order to do so, we want to use electricity for heating. Well, that's easier said than done because an electrical heater consumes electricity, and electricity is more expensive than gas. So how are you going to do this? Well, the way that this is going to be done is by means of what we call smart energy. It means that if you have a business process that generates heat, you're going to be focused on trying to make that usable for someone else, so someone else doesn't need to burn gas. And that's being done in the form of heat grids, and it's being supported by governments, both on the European level, but also all the way down to city levels, where grants are being awarded to companies who apply smart energy. Now, the way that we're getting involved, that we've gotten involved with all this, is in the sense of the creation of actual energy-producing data centers. And it has a relationship with our technology. Our technology produces hot water, right? We all know data centers produce heat. It's usually captured in air. It's difficult to use. But hot water is quite good to reuse. It's fairly easy to do so. So we're actually involved now, all of a sudden, in some very big projects, ranging from 2 to 100 megawatt facilities, where our technology will be used to generate heat. What you have to understand is that the consequence of this is that we're actually in the process of building data centers without a primary cooling infrastructure. Because the cooling infrastructure is actually the heat grid that it's rejecting the heat into. So that means there's also no energy consumption for the cooling side of the data center. Now, these energy companies are bringing up a challenge with us. So they're challenging us to reach a temperature of 70 degrees centigrade. Now 70 degrees is a bit of a magic number here. Some of you may be aware of that because that's a temperature that kills Legionella. And that's something that you can, if you reach those temperatures, you can feed directly into a heat grid. Currently, today, in our own labs, we have an experimental system running a low density or a medium density cloud environment that is already producing 65 degrees water. So we're only 5 degrees away from this challenge. There is a little hurdle to tackle there, and that's where we are developing. We're trying to establish relationships with manufacturers to increase some chip temperatures to reach that 70 degrees. What we're delivering today already, what we're implementing today already, is environments that are generating 50 degrees centigrade of heat. It's the normal rejection temperature of our environment. Now, there is a little thing that is an additional advantage to all this work that we're putting into this. Because if you build a data center that doesn't need cooling infrastructure, that doesn't need to put any energy in to cool down servers, and you're giving that energy away to a heat grid, it's very cost effective, of course. But it's actually even more ridiculous than this, because energy companies are actually willing to pay for that heat. So here you get free cooling, free cold, and you're getting money for it as well. Now, I already told you, the current installations that we're creating are already producing 55 degrees centigrade heat. So that means we can cool with 40 degrees centigrade. We don't really need any cooling infrastructure. One of the implementations is at Ecorex in Holland. It's a small regional data center that is about 1,400 square meters of air-cooled environment, and that's currently has an energy load of about 750 kilowatts. It's a bit outdated data center. It was built in the late 90s as a regional point of presence. And in the meantime, over the years, it has been upgraded a few times and it's been refurbished. But they're running into the limits of what they can do. So they had this little room left over with about 65 square meters, and they decided to have a go at immersed computing. Now, what we've created there is something that really quite extraordinary. Of that 60 square meters, we have used 35 square meters, which contains 300 kilowatts of compute. And the interesting thing, this is based on two customer cases. A hosting environment, a high-density hosting environment, which is consuming around 16 kilowatts of energy and producing 16 kilowatts of heat. And that has high availability requirements. There's a second customer, which is a GPU-based cloud cluster. Now, you all know that's code talk for something else. And that has very low availability requirements, and it's consuming about 32 kilowatts per module. Now, the disruptive element around this is the whole business case. This environment is using electricity, so the hosting modules are facilitated with A and B power sources behind the UPS environment. The GPU environment is supplied with a bypass for around the UPS environment, so that's feeding directly into the electrical grid because of its low availability. Which means that there is no overhead, no additional load on the UPS environment. The water infrastructure is set up in such a way that the hosting side has about 30 minutes repair time possibilities without any cooling supply whatsoever, with that 16 watts. The GPU cluster is running at the edge of what it can do with that cooling supply, so because of its low availability requirements, that's not a problem. It will shut down if there is a cooling failure. But the whole cooling infrastructure is based on a water pipe and a dry cooler alone. And that's generating 50 degrees centigrade heat. Now, here's the interesting thing that happened. The owner of this data center, Willem Jan, he's not here today, he was here earlier this week, there is a company located right behind this data center. That's a car wash. And this car wash is creating a lot of heat. So the owner of the car wash went over to the data center and asked, well, I heard that you're going to do something with this immersed computing thing, and you've got this warm water coming out. Would you mind if I use some of that? So, well, Willem-Jan is Willem-Jan, so he struck a deal, because whenever somebody else uses some of his heat, he doesn't have to cool it, so it's an energy saver. So, a pipe is being put in place towards the car wash, so they can use some of the data center heat that's coming out of the system. Another neighbor of this data center heard about this and came knocking on the door. Hey, can I get some of that heat, please? I would love to have some. This guy was planning a whole new heating installation in his building, right? So instead of investing in a whole new heating environment, he's going to get heat from this environment as well. And this was about 5 months ago that these conversations took place. In the past 5 months, a lot of additional industries in the immediate vicinity of this data center came knocking on the door. And what is going to happen now is that this is going to be one of those very few installations, or very few areas where a local initiative is taking place that is putting in a localized heat grid based on one data center implementation. What this illustrates is that heat demand is everywhere, as long as you can deliver it in the right shape. So back to the actual business case, this whole environment has a very good TCO model. So from the CapEx point of view, there is no building requirements for this type of infrastructure. I mean, a concrete floor and you need some walls. There's no expensive cooling infrastructure required. A simple dry cooler suffices, and if you can reject the heat to a reuser, it's even more advantageous. There's no air infrastructure at all, except for the infrastructure you need to supply human life in the building, like any other office building. So just a little bit of ventilation to get oxygen in the room. Instead, there is a low-cost water infrastructure. When I say low cost, don't confuse that with low quality, because a water pipe is cheap to put in place. From the operational cost point of view, as a minimum, I don't even have to explain the energy advantages, I assume, because without the cooling requirements, we're also saving energy on the IT side, because there's no moving parts in this entire installation, with the exception of the pump that circulates the water in the water infrastructure and the fan coils in the dry cooler. So the whole data center cost is greatly reduced. And that is advantageous to both the operator of the data center and the customer of the data center, because the customer pays less as well. So the entire business model for this data center is now rapidly changing based on this infrastructure. There is also reduced maintenance. So besides all the air cooling infrastructure you don't need, there is great opportunity in consolidating the IT in this type of infrastructure. So you have less IT to maintain. And there's an additional benefit that doesn't always come when you expect it, but that came relatively unexpected. That's the hosting environment in this case. When you're running hypervisors and you're paying licensing costs, a lot of those licensing fees are based on the amount of CPUs. Now, this consolidation has drastically reduced the amount of CPUs that are involved in creating this cloud environment. So all of a sudden, the licensing costs for this cloud platform are chopped in half. Well, that's a big money saver as well. So I would like to point out another example. Some of you may have seen on a stand the GPU configuration that we have. That has been made as a part of a development for a company called Beehive. Beehive is a new value-added reseller for Asperitas systems. They integrate systems in our solution, and they came to us with a challenge before they were able to do this integration, that we want to have a more professional cryptocurrency mining environment. We want to have a future-proof mining model, and that future-proofing also means that we need to address sustainability. And it needs to be cost-effective. I mean, we all know cryptocurrency is not willing to pay anything that they don't need. So it needs to be extremely cost-effective. And they want to distribute this as an integrated mining solution. Now, what you have to know about Asperitas is that we love a challenge. We love these type of problems and we love solving them. So this is what we came up with. A world record GPU density solution. So inside one of our systems, we're facilitating currently 288 GPUs on the same footprint as a 19-inch rack in a device that's only half the size of a rack. And that has no air circulation, it makes no sound, and it uses no chillers. And instead, it's producing warm water. So an installation like this has incredibly low site requirements, especially when you're talking about cryptocurrency. All you need is a floor, a wall, and maybe a lock on the door to protect all the GPUs. And an internet connection, because you want to do some mining. And the whole system requires power and water to run. That too. But that opens the door to a whole new implementation of facilities for this type of environment. So that opens the door to a whole new deployment strategy as well. So what we're looking at now is that we're positioning these cryptocurrency pods in places where there is a heat demand. So we're actively looking for places where people want to use heat. Think about swimming pools, hospitals, well, it's on there, right? And the advantage of this is that wherever you go where heat can be reused, you're getting a free facility. You're not paying for the facility because you're solving that problem by going there. So you're creating synergy between two completely different business models. And one of the examples that we're involved in is an urban farm in the Netherlands, in The Hague. A company called Urban Farmers. They've got an aquaponics environment where they grow fish. One of these systems is going to be responsible for the base load of this aquaponics environment. So these guys are actively growing fish with chips. I mean, that's a bit lame, but still. Thank you. So actually what we're creating here is something very interesting. We're doing this not entirely by accident, because this is actually what we described in the white paper already before we even got in touch with these people that we developed it with. Because what we're creating here, we're getting into areas we can penetrate beyond data centers. We can penetrate areas where data centers cannot go, because we are focusing on the heat reuse. So we're setting up these installations that range between 30 and 600 kilowatts that are going to be distributed in areas where the heat demand is. Where is the heat demand? It's wherever we are. Where are we? We are the edge. What is the edge of the network? Everybody knows the term edge, I assume. It's us. It's not the edge of a city. It's the edge of the network. That's our mobile devices, that's our internet connections, that's wherever we do our work and where we live. And these facilities have no or minimized cooling requirements. We're actually already involved with a partnership. Carnot, you may want to write it down if you haven't heard of that, Q-A-R-N-O-T. It's a French company that positions heaters in buildings, and those heaters actually contain CPUs and GPUs. And they've got a thermostat. And there we have examples of compute being a result of a heat demand. Now this is a bit mind-blowing for most cloud platforms, of course, but still. Looking at the broader industry interest in edge, there is a tremendous amount of interest in edge deployments for Internet of Things, blockchain, machine learning, AI, And there's also an interest for a lot of cloud environments to move to get access into the edge, to get closer to the edge of the network. And this is something that can be done with the infrastructure that we're deploying now. So digital architectures are changing rapidly. We're looking at an increase in thermal properties of CPUs. Look at the new Intels, look at the new AMD CPUs. They're generating a lot more thermal energy than the CPUs in the last few years. We're also getting more challenges around GPU-based cloud services, right? So this requires a convergence of HPC and cloud. Now, in order to address these challenges, Asperitas thrives on partnerships to drive our technology, to drive our principles, and to accelerate the change which is necessary in this industry. And Asperitas engages with the partners who get our technology and who get our customers, who have the industry pedigree and who can deliver our technology in a solution that really realizes all its benefits. So, in the light of this, we are partnering up with Boston, UK, and we're here to announce that today as well. Boston, UK has a track record of 25 years in the industry with a close alliance with one of our partners, Supermicro. And to enforce this partnership, I would like to invite Glenn Rosenberg from Boston, UK, onto the stage, and Leon Lips from my team to join me and formalize our intentions to work even more closely together. Hi, that'd be great. So, and I would like to ask Glenn, would you mind elaborating a little bit shortly, because the time is running out, on reasons for partnering up with us?
So back in...
I think it was on, yeah.
Yeah, so back in 2008, we met with a very bright CTO called Chad Attlesey. And at the time, he was a leading exponent of immersive computing. His company developed a product called the Detonator, which is probably a very badly named product nowadays, but back then it was highly advanced. And what it allowed people to do were run applications at 200% performance at about 1,000 times the efficiency that they would do in air cooling. When it became productionized, Boston was the first company to introduce it into Europe and the Far East, pretty much everywhere outside of the US. So we got liquid cooling, immersive cooling at a very early stage. If we now step forward 10 years to 2018, Asperitas are turning it on its head. They've addressed so many of the issues that conventional immersive computing has. Serviceability, cost of the liquid, the actual design of the tub, whatever term you want to use for it. And if you go into a standard immersive cooling data center at the moment, you'll see massive tin tubs with oil pads around it and rudimentary crane hoists to service the product. Asperitas took that and changed the serviceability to be part of the actual system design. So they actually have looked at the whole delivery method of the immersive system. They've also totally revised how you look at both the mechanical engineering and the thermal dynamics of immersive computing. And it's probably the most impressive change that I've seen, certainly in this type of technology, for a number of years. Boston love technology that's cutting edge. If it's disruptive, even better. We've got a track record of 25 years of bringing that to market, and we're very much looking forward to changing the way people view immersive computing and working with Asperitas. So thank you, Rolf.
Thank you very much, Glenn. So we're actually going to sign this partnership right here, right now on this stage. Let me hold that for you. Right. Okay, that concludes my presentation. It's been an honor to be here. Thank you very much for your time, and I hope to see you all on the stand. Come and check out the technology. You can see everything that I just presented in real life, fully operational, under load here at the event. Thank you.
Brink, Rolf Brink, ladies and gentlemen. Congratulations. This is the first signing we've had on stage. So please, another warm round of applause for this guy who is a real unorthodox thinker to solve a problem with a totally different approach. You know, they say conventional thinking gives you conventional results. So if you want unconventional results, use unconventional thinking. Well done, Rolf.
Thank you very much.
Yes.